Obviously, an unfinished basement has bare walls, with all of the studs of the walls, floor, or ceiling joists visible. You will probably see the electrical, plumbing, and ductwork as well. This is much easier to inspect than a finished basement. Finished basements are livable areas that typically have drywall or panel coverings. In this environment, what we see is limited, but there are some telltale signs of problems that we will discuss later. As a safety precaution, never walk into a flooded basement because hot outlets could be submerged underwater. Call a water removal specialist to safely remove the water. Recall from our first lesson that groundwater and the water table surround your foundation walls, and water infiltration is the most significant problem of basements. When the floor is dry, walk around and check the walls, floors, and appliances for mud stains or mud rings. When you see signs of flooding, keep in mind that regrading the landscape around your foundation can reduce this from the walls. However, water entering through a slab floor is a sign that there is pressure being exerted on the underside of the floor. If you have minor cracks on the floor or foundation wall, you should seal them with a hydraulic cement and then coat them with an epoxy or something with a cement base. Dampness occurs because cool air cannot hold as much moisture as warm air and results in a higher relative humidity. Depending on the temperature and humidity, you may see condensation on the water pipes or foundation walls. To make sure it's not a leak, wipe away some of the moisture by a plumbing joint. The water should not reappear. To rid your basement of excess moisture, consider a dehumidifier as shown in the picture on the right. For example, if you have a leaking spigot, those drips can add up to over 75 gallons of water being lost every day, and guess where all that water ends up? Long horizontal cracks are usually freeze cracks and occur when water freezes with the dirt, expands, and then cracks the wall. Eventually, the wall won't be able to stand the pressure and will bow in or snap. If you have a bowing wall, there will probably be both small and large cracks that will inevitably widen with more and more water. Call a structural engineer. In addition, look for efflorescence on the walls and in the corners. Look for peeling or flaking paint as a sign of surface deterioration. And remember, a very porous wall may even have damp spots. Mold and mildew should be addressed immediately. Molds need moisture and nutrients to grow, and many species of mold reproduce by releasing their spores into the air. These spores can end up inhaled or on clothes, giving rise to new colonies. In fact, studies have shown that airborne mold spores are more numerous than pollen grains and can cause allergic reactions or sickness. Common symptoms are irritated eyes, nose or throat, headaches, nausea, and other allergy-related feelings. Call a specialist. All exposed wood supports should be probed with your awl for structural integrity, especially along the foundation wall. Also, check the sill plate located at the top of the foundation wall. If you happen to see any deteriorated end sections, these can usually be rehabilitated by placing another piece of wood alongside the stud and securing it to an unaffected area with a screw. Also, look for signs of insects, such as numerous holes in a stud or dust piles on the floor near it. Finished basement walls are obviously more difficult to inspect. Leaks are usually visible as dark stains on drywall or rotted, warped panels. Look at the bottom edge or trim of the wall because this is where water settles and eventually will destroy the wall. A common area of water seepage is where the foundation wall meets the floor. Water flows down the outside of the wall and can make its way in through the pores. If your floor is bare slab, you will most likely have small hairline cracks. Ignore these, but address large cracks, regardless if they're leaking or not. In addition, if you see reddish iron stains or greenish blue stains on the floor, this indicates that an overhead pipe is dripping. Look at the bottom steps. Wood may be stained or rotted, and metal may be rusted. These are all signs of leaks. Ceiling joists in basements are generally in better condition than joists in a crawl space because they're not constantly exposed to the elements. The portions of the joists and girders most vulnerable to wood rot are actually in contact with the foundation walls. Girders are the main support beams of your house and are often supported at both ends by the foundation wall. There will probably be a notch where the beam rests. There should be at least a half-inch clearance on all sides and ends of the girder to ventilate. Otherwise, moisture buildup will lead to decay. For proper support, at least 4 inches of the end should be resting in the notch. If you see any rot or deterioration, this problem can usually be corrected by adding a support column near the foundation wall. Adjustable screw columns, as shown in the picture on the right, can be used to brace sagging areas as well. However, I recommend letting professionals handle this because new stresses can be added and cause more cracking. You will definitely see holes cut out for plumbing, wires, and other things. Keep in mind that a beam is only as strong as its narrowest section. Holes should be cut right in the center where there is no reduction in the beam's strength. Bracing will also be visible. This is necessary to transfer the floor load from one joist to another. You will see either cross or solid bridging. Cross bridging is wood or steel pieces diagonally installed to form an X. Solid bridging is simply horizontal solid blocks between joists. Check these for obvious problems. Finished basements usually have carpet or linoleum present. Check the carpet for stains or water pools near the foundation walls. Carpet will make a squish sound when saturated, and linoleum corners tend to pull loose. If you have a sump pump, there must be floods from time to time in your basement. The sump pump should not be located where someone can trip. It should be in the corner with a drain pipe under the floor slab. Many of these are submersible pumps and can't be seen. If yours is visible, you should test your sump pump about once a year. Use a hose and fill the sump hole with water until the float rises and turns on the pump. If you hear a high-pitched squeal, it indicates that the bearings are bad. If it just sits and hums without pumping water, this means the impeller is probably jammed. If water isn't leaving the sump hole, the slots are probably clogged. Also, look for leaks at the fittings, and make sure your drain pipe isn't discharging right outside of the foundation wall. A diaphragm pump is harder to test because it does not have a rod to lift. Instead, it uses water pressure. The hard part about testing this kind of pump is getting the right kind of pressure. Experts recommend using a hose and only raising the water level to where the drain pours into the sump hole. If it hasn't turned on by then, something is wrong. The only way to test your basement floor drains is to run a hose directly to them. Most of the floor drains I've seen have some type of clog farther along down the pipe, so let the hose run for a few minutes. Ideally, you don't want your drain to be connected to the sewer system because of the possible backflow of sewer gases into your house. However, if this is the case with your drain, plumbers recommend pouring mineral oil on top of the water seal. In addition, any condensation lines that run to the drain should have at least a 1-inch air gap to prevent cross-contamination. The electrical inspection can start as soon as you turn on the lights for the stairs. There should be a switch at the top and the bottom of the stairs. Once in the basement, there should be some type of switch to illuminate the main area. Unfinished basements usually have a pole chain light of some type. Finished basements should have a switch for lighting at each point of entrance or exit. For safety purposes, all light fixtures need a bulb to prevent little fingers from exploring. Fluorescent lights have a habit of not working well in damp environments, as discussed in the garage section. Their terminal pins tend to erode faster in damp environments, and the lights can take an unusually long time to warm up. In an unfinished basement, you have the advantage of seeing all of the wiring and where it is run. Look for damaged wire, bare wire, and open splices or covers. There should not be any cut wires trailing nowhere. In older basements, there may be knob and tube wiring present. This consists of porcelain insulated knobs, tubes, and flexible non-metallic tubing for support of the two insulated wires that run independently a few inches apart from each other. One is the hot conductor, the other is the neutral return. These wires have no ground. This can be dangerous when standing in a basement with a moist or wet floor. Grounds can usually be added without replacing all of the wiring. Knob and tube wiring is probably grandfathered into your electric codes. As long as the wire insulation is intact, there's no necessary need to replace it. This low voltage comes from the secondary winding of a small transformer. Normally 120 volts is on a primary line, which will send about 20 to 30 volts to a secondary line. Low voltage wires are not considered an electrocution hazard, so you may see a large tangle. As long as a primary wire is not accessible, there shouldn't be a problem. Any 3-prong receptacles should be checked for proper ground with your plug-in tester. Only a 3-prong receptacle that feeds off the load side of a ground fault circuit interrupter doesn't require a ground. And for future reference and ease of memory, label any ungrounded receptacles. Many do-it-yourselfers install 3-prong receptacles on old 2-wire cables, and this is in violation of electric code unless it's fed by a GFCI. Copper pipes are known to spring pinhole leaks, which may spray off to the side or flow down the pipe and drip off. You've probably seen greenish-blue buildup. That is the reaction of slightly acidic water, the copper, and the solder. Soft copper that comes in rolls is known to change its diameter when water freezes. When the water thaws, the pipe stays in a position that won't allow new copper fittings to go over the pipe. Plastic pipe, also called CPVC, is usually pale colored. The white plastic pipe you've observed, called PVC, isn't normally used for water lines throughout the house, but rather for bringing water into the house from the city main or well. The obvious problems with plastics occur when it gets cold. Plastic cracks easily, and the older it gets, the more brittle it becomes. This pipe is known for large splits in long sections where there is freezing water with pressure behind it. You also want to check all joints for leaks because it is very easy to cross-thread plastic, and it may have been bumped or hit at some time. Any metal pipe that is screwed into a plastic female fitting should be suspect because of the plastic's tendency to crack. Look for slow drips coming from female fittings. These could be streaming from hairline cracks too small to be seen with the naked eye. Any water tracks on the pipe are a telltale sign. Also look for red rust stains on the pipe or concrete floor. Polybutylene is flexible gray pipe that has had its share of problems with fittings. Leaks usually spring up around the ring joints. These joints are not supposed to be glued or tied down with hose clamps. There are also leaks present where the tops and bases come together. If there are any metal clamps holding up the soft and flexible polybutylene, this is not allowed because metal can easily cut into the pipe. Galvanized pipe is metal that has been coated with zinc. The main problem with this type of pipe is rust that forms on the inside of the pipe. If you notice a low water pressure at water outlets around your house, rust may very well be the cause. These particles have a habit of breaking off inside of the pipe and flowing to areas such as shut-off valves and sinks, toilet refill valves, and washer screens. On the outside of the pipes, be on the lookout for rust on the threaded joints that connect the pipes. Drain lines also have their share of problems, especially when two different pipes are connected to each other. Look for cracks in the fittings, larger pipes that feed into smaller pipes, and pipe runs that are not necessary. Turn on the water upstairs and look for leaks in the drain lines. Common leak spots are the shower or tub traps and toilet flanges. If a seal is leaking, the surrounding wood will likely be wet to the touch. If dry, stains or rot will indicate current or past problem. A leaky trap will have water dripping from the lowest point. Also look for long sections of unsupported pipe, sagging pipes, or pipes with upward slopes. Most plumbing codes state that you cannot glue different pipes together, although they can be screwed together. If there are steel lines connected to cast iron, look closely where they connect, because steel has a tendency to rust through at this point. If accessible, look at the water main entrance into the house. A shutoff valve is required. However, do not test it because the valve could get stuck or break off from lack of use in a permanent position. Just make sure one is present, as well as some sort of anti-backflow device, which we will discuss later. Our final topic of basement plumbing is basement bathrooms. If there is a shower present, ventilation is a must. A lot of codes state that if a window is present, a vent is not needed. However, this is illogical because no one opens a window in the winter. Failure to vent moisture adds to the problems we've already discussed earlier. Almost everything we've covered for basements applies to crawl spaces. The Federal Housing Administration's minimum property standards permit the ground to be just 18 inches below floor joists and only 12 inches for girders. So, getting in there may not be possible. The most important points about a crawl space are proper ventilation and a vapor barrier. There should be at least 2 vent openings on opposite foundation walls for every 1,500 square feet of crawl space. Any professional will recommend a plastic tarp for a vapor barrier. With extreme heat and moisture that builds up, you should definitely install one. Insulation is also crucial to prevent freezing pipes. If no vapor barrier is present, more moisture will be contained within the insulation. And from our attic lesson, we know what that leads to. Another common problem is sagging beams, noted as dips in your floor. Also check the beams for insect damage and rot. Have someone flush the toilet and look for leaks in the plumbing and drain systems. The same information we discussed inside applies in the crawl space as well.